Galaxies in our universe seem to be achieving an impossible feat. They are rotating with such speed that the gravity generated by their observable matter could not possibly hold them together. They should have torn themselves apart long ago. The same is true of galaxies in clusters, which leads scientists to believe that something we cannot see is at work. They think something we have yet to detect directly is giving these galaxies extra mass, generating the extra gravity they need to stay intact. This strange and unknown matter was called dark matter, since it is not visible. The OSQAR experiment at CERN searches for hypothetical particles called axions and studies the properties of a vacuum. According to some theories, axions could be components of dark matter, and they could help to explain why there is more matter than antimatter in the universe today.
In this experiment, we are looking for low energy particles that could be responsible from dark matter and dark energy. We have a laser beam that sends photons through the aperture of a LHC dipole, and we expect from the collision of this photon flux with the magnetic field lines to produce new particles that could be responsible for dark matter.
The OSQAR researchers shine the laser into a vacuum chamber containing a barrier that stops photons. If they glimpse light on the other side of the barrier, the researchers deduce that axions have travelled through and transformed back into detectable photons on the other side.
If this new particle at low energy exists, they should be weakly interacting with matter. That means that if we make a barrier at the end of the magnet with the photon flux, we can absorb all photons, and only these particles that has been transmitted could go through this barrier to reappear in form of photon in the second dipole that is located behind the wall. This is why this experiment is called a light shining through the wall experiment.